Here we're asked to find the highest common factor of 70 and 56. So whenever we're asked to find the highest common factor, the method that I like to use is to use some number trees to get the prime factors. I know that 70 is equal to 7 times 10. 7 is a prime number, so I will circle that. 10 I'm going to do the same for. And of course I get 2 and 5, because 2 times 5 make 10. Now both of those are also prime numbers, so I'm going to circle those as well. And I know now that the prime factors of 70 are 7, 2 and 5. Now let's take a look at 56. I know that 56 is equal to 2 times 28. 2 is a prime number, so I'm going to circle that. 28 I know is 2 times 14. 2 is a prime number. And 14 is 2 times 7, both of which are prime numbers. So I'm going to circle those off as well. Now I'm going to compare my two number trees. I can see they both have a 7 as a prime factor, and they both have a 2 as a prime factor. So what I'm going to do now is multiply together those two numbers that they both had in common. So they're common prime factors. 2 times 7 gives me 14. And therefore the highest common factor between 70 and 56 is 14. A container of water was measured to have a volume of 50 centimetre cubed to the nearest centimetre cubed. We're asked to find the error interval for the volume of water in the container. So what I would do here is I would sort of draw a little number line using the fact that it's to the nearest centimetre cubed. So I'm going to put 50 there, and then I'm going to think, well, if it was one less, then it would have been 49. And if it was one more, it would have been 51. So here then, what I can imagine is if I do like a little halfway point between the 49 and the 50, and between the 50 and the 51, I have the region, that error interval, for the volume of water. I know that halfway between 49 and 50 is 49.5, and halfway between 50 and 51 is 50.5. Therefore, my error interval is that the volume of water is going to be less than 50.5, but it's going to be greater than or equal to 49.5. And that's all we need to do in a question like this. So this question here is going to test your calculator skills. We want to use the calculator to find the value of sine 75 plus 2 times 1.2 all over the root of 12 times 14 and then minus 2. Our top tip here, make sure you use the fraction button. That way you're not going to have to worry about brackets. However, one bracket you will need to worry about is, and this is another potential mistake you could make, is make sure that you close the brackets after writing 75 for the sine. You just want sine 75, then you close the brackets, and then plus 2 times 1.2. Another place where there could be a mistake is this region here with the square root, because the square root is just the 12 times 14, not the minus 2. So make sure after you type in that 14 under the square root, you then press the arrow button to move to the side to then get the minus 2. So putting this into the calculator, I get 0.307068561. Make sure you write your full answer, just in case you round incorrectly, so that you still get a first mark. And then here we need it to 3 significant figures. So here I can see I've got my 3 significant figures, and if I look to my 4th significant figure, I can see it's a 0, which is less than 5, and therefore I don't need to do anything there. 3 significant figures is simply 0.307. A person's wage is divided in a ratio of 5 to 3 to 2 between bills, spending money and savings. 60% of the amount spent on bills is rent. Now let's write out this ratio, 5 to 3 to 2. We know that the 5 part of this refers to the bills. And we're told here that 60% of the amount spent on bills is actually rent. Now, we're given the extra bit of information on the next line, that the rent bill is $1,200 per month. That must mean then that the rent is equal to $1,200, which is equal to 60% of the bills. So let's make this little equality here. 1,200 equals 60% of the bills. So if we know that, then we can work out what 1% is. We can go down to 1 by dividing by 60. Now we'll do the same on the other side too. 1,200 divided by 60, which gives us £20. So we know that 1% of the bills is equal to £20. So now that we know what 1% is, we can easily go up to 100% and find the full amount that those bills are equal to. So if we times both sides by 100 to do that, we find that the bills comes to a total of £2,000. So now we know that the total amount of the bills comes to £2,000. Let's include this in our labelling, okay? So I'm just going to add on here that 5 part of the ratio is equivalent to £2,000. Now that I know that, I'm just going to write that as an equality. I'm going to say that £2,000 is equal to 5 parts of this ratio. And it's really important to write everything down nice and clearly like that so that we don't get lost along the way. So now that we know that 5 parts of the ratio is 2,000, we can easily go down to work out what 1 part of the ratio is. And we can do that just by dividing both sides through by 5. So now I'm dividing both sides by 5, and I end up finding that 1 part of this ratio is equal to £400. So now going back to the question, when it says that the ratio 5 to 3 to 2 is between bills, spending money and savings, that means that the savings part of this ratio is represented by the number 2. So ultimately in this question, where we're asked to work out the amount of money saved each month, we need 2 parts of the ratio, which is 2 times 400, which gives us £800. And that there is our answer. A person buys a new car for £65,000. They're told that it's going to depreciate in value by 7.6% each year. And we're asked here to calculate the value of the car after 5 years, giving our answer to the nearest pound. So here we need to remember it's depreciating in value. So if we consider the original value to be 100% and take away that 7.6%, we're left with 92.4%. Now that's really helpful because we can change that percentage into a multiplier. And any of these compound interest or depreciation questions are made so much easier if you have this multiplier. Simply convert that percentage to a decimal, 0.924, and you do that by dividing by 100. So this is how we're going to do it. We're going to take the amount that the car cost, 65,000, and times it by our multiplier to the power of the number of years. Now this method works for any of these questions. Now that we've got this formula, all we need to do is to put it into the calculator. So when I do this, I get to the nearest pound, as the question wants, £43,780. And see how simple that actually was. So let's just go back and think about it again. So we always start with 100%, that's our original value. And if we're depreciating the value, we subtract the percentage. And if it's going up, like compound interest, then we add the percentage. We then find what that percentage is. In this case, it was 92.4%. And take whatever you have and divide it by 100 to get your multiplier. Then finally, we have our original value. That could be how much money you have or how much something cost. And then you times it by our multiplier to the power of the number of years. So in this case, that was 5. It could be something different to years, but probably it's going to be something like that. So it's the power of the number of years in this case. And that's how we do it. And then it's just calculator work. So I hope that's clear and you feel ready to have a go at another question like that in future. Line 1 has the equation 2y equals 3x minus 3, and line 2 has the equation y equals 5 minus 2/3 x. Here we're asked to find out if the lines are parallel, perpendicular, or neither. And the thing we really need to remember here is that y equals mx plus c, where m is the gradient. So that number multiplied through by the x, when the equation's in this form of y equals something, is the gradient. So let's start off by looking at line 1, which has the equation 2y equals 3x minus 3. Now this isn't of the form y equals something, it's got 2. We need to deal with that. And we do that simply by dividing it all through by 2. So that gives us y equals 3 over 2x minus 3 over 2. So comparing this to y equals mx plus c, we can say that the gradient of line 1 is equal to 3 over 2. Now let's look at line 2. So here we're told that line 2 has the equation of y equals 5 minus 2/3 x. Now this is written in the opposite way, so a lot of people could get confused and say 5 is the gradient. But it doesn't matter the order that it's written, it matters that the gradient is the number times by the x. So in this case, the gradient of line 2 is minus 2 over 3. Okay, so now we've got the gradients of line 1 and line 2. And we need to think, are they parallel, are they perpendicular, or are they neither? Well, we need to know that if we had two parallel lines, they would have the same gradient. And in this case, the gradients aren't the same. So we can say that these lines are not parallel. Next up, let's have a think about if they're perpendicular. We should know the rule that states that if two lines are perpendicular, their gradients would multiply together to give us minus 1. So let's test that with this question. So if we did 3 over 2 and multiplied it by minus 2 over 3, we do indeed get minus 1. Now this means that they are perpendicular. If, however, this product didn't equal minus 1 and the gradients weren't the same, we would say neither. But in this case, we can say that lines 1 and 2 are perpendicular. So the salaries of 80 employees of a company are given in the table below. So we've got this nice little summary table and we're asked to write down the modal class. So what we need to know here is that the modal class is the most common interval. So what we need to do is to go and have a look at this table and find which one has the highest frequency. So I can see that the salary range between £20,000 and £30,000 is the most frequent and therefore the most common. So that is the modal class. And make sure that you write that whole interval. We don't just write 25 or anything, that isn't what they want. They want that interval of salaries. Now we're asked to work out an estimate for the mean salary. So it's a 4-marker this, it's going to be a bit trickier, but there's a really nice straightforward method to it. So the first thing I'm going to do is I'm just going to copy down this table here just so I can scribble all over it, okay? Okay, so to work out an estimate for the mean salary, we need to take the midpoint of the salaries, and then once we've worked out the midpoint, we need to work out what the midpoint times the frequency is. Now, all this is going to be part of our method, so if we fill it all in, all will be good. So the midpoint between 0 and 10,000 is just 5,000. So I'm going to write that in here. The midpoint between 10,000 and 20,000 is 15,000. So I'm going to write that. Midpoint between 20 and 30,000 is 25. 30 and 40,000 is 35,000. And the midpoint between 40,000 and 50,000 is 45,000. So now we're going to times the frequency by the midpoint. So 13 times by 5,000 gives me 65,000. 14 times 15,000 gives me 210,000. Now 25 times 25,000 ends up giving me 625,000. 17 times 35,000 ends up giving me 595,000. And finally, we've got 11 times 45,000 gives us 495,000. So let's remind ourselves of how we work out the mean. So mean is always going to be the sum of values. Now in these types of questions with class intervals, That means the sum of the midpoint times the frequencies. And then we divide it by the number that there are. Now in this case, we're told that we have 80 employers. That in this case is going to be what n is. So let's work out the sum of all those midpoint times frequencies. So we're just going to add up the 65,000, the 210,000, all of those, we're going to add those up together, and we end up getting 1,990,000. And we're going to divide that through by 80, which is n. That gives us now a mean salary of 24,875. And you know, if you look at the salaries that are in the table, it kind of makes sense, doesn't it? Like that is a number that falls in that range. It's actually in that modal class as well, which you'll often find. So let's have a look at the next part. An employee was randomly selected and asked what their salary is. Give the probability that their salary is less than or equal to £30,000. Give your answer as a fraction in its simplest form. So let's remind ourselves of that table, here it is, and let's think, less than or equal to £30,000 is going to be all of these three salary ranges. How many people are there in total with those salaries? So we've got 13 plus 14 plus 25 different people. Now, adding those up together, we end up finding that we have 52 people with salaries in that range. Now don't forget we had 80 people in total. Of course we can remember it from the earlier part, or we could just add up all those frequencies. Doesn't matter if we forgot that they already said it. So the probability is going to be 52 out of 80, which will simplify down to give us 13 over 20. Of course we can work that out ourselves, but as we always have a calculator in these papers, you can always just type in 52 over 80 on the calculator, and it will normally give you the most simplified version of the fraction. A solid bar is in the shape of a triangular prism. The bar has a mass of 1,200 grams. And we're asked to calculate the density of the bar to two significant figures. Now let's remind ourselves of the equation for density. Density is equal to mass divided by volume. Now, in this particular question, we know the mass. We're told that it's 1,200 grams, and that's in the units we want because we need density in grams per meters cubed. But we don't yet know the volume. Now, the volume of a prism like this one can be worked out by using the equation that states volume is cross-sectional area times by the length. So that's what we're going to have to do to work out the volume of this. We're going to have to first work out that cross-sectional area and then times it through its length. Now looking at the diagram, I can see the cross-sectional area is that of a triangle. So I'm going to do half the base times the height. That ends up giving us 1/2 times by 0.2 times by 0.4. And putting that into the calculator, I find that that gives me an area of 0.04 metres squared. So now I can use that to work out the volume. I know that the cross-sectional area now of that equation is 0.04. So I can say that the volume is equal to 0.04 times by the length of this prism, which is 0.9 metres. So I'm going to pop that into my equation too. So volume is 0.04 times 0.9. Now if I pop that into the calculator, I find that the volume is equal to 0.036 metres cubed. Now I do have all the information that I need to be able to calculate the density. Density is the mass, 1,200, divided by the volume, 0.036. So popping that into the calculator, I find that density is equal to 33,333.333 recurring. However, this question, it doesn't just want that as the answer. Always go back, check the question at the end. You can see that they want it to two significant figures. Not two decimal places, two significant figures. So that in this case will be 33,000 grams per meters cubed. Here we're told that a gardener wants to place a border around a region of a garden. The dimensions of the region are shown below. So here we can see we've got this 3.6 by 7.5 triangle. However, we don't know the length of the hypotenuse of it. We're told that each roll of border is 5 meters long, and we're asked to work out the least number of rolls of border that the gardener will need. So this means we need to work out the perimeter of this triangle. Now to do that, we need to work out this hypotenuse length. Let's call it x. Now this is a right-angled triangle, so we can work out its length by using Pythagoras' theorem. Pythagoras' theorem states that the length of the hypotenuse squared is equal to the sum of the square of the other two sides. So here we have x squared equals 3.6 squared plus 7.5 squared, which gives us x squared equals 69.21. Now to get x on its own, we need to square root that, which leaves us with 8.319. Now we have enough information to work out the perimeter of this triangle. So let's do that. Let's get this perimeter. It's going to be equal to 3.6 plus 7.5 plus 8.319. And that ends up giving us a total for the perimeter of 19.419. So let's go back to the question now. We're told that each roll of border is 5 meters long. So we need to work out, well, how many of these 5 meter long packs of border do we need? So if we take the 19.419 and divide it by 5, we will see that we get 3.8838. Well, that's how many rolls of border we need. We can't get 0.8 whatever of a border though. So we're going to round up. We're going to see that we need 4 rolls of border, and that is the least number of rolls of border that the gardener will need. So the diagram below shows 3 regular pentagons, and we're asked to find x. So when working this out, the fact that they're regular pentagons is really important because it tells us that every angle in the pentagon is identical. Here is a little method that we can use to work out the interior angles in a pentagon. If you take one point and see how many triangles you can draw, I can see that I can make 3 triangles. I know that each triangle has an angle of 180. So that means 3 times that 180 gives us 540. Now that's the sum of all of the interior angles. So if I take that 540 and I divide it by 5 because there's 5 angles in there, I can see each interior angle in a pentagon equals 108 degrees. So see here I can label our diagram, and actually this is becoming quite clear what we need to do next. We know that the angle around a point is 360. So if from that 360 we take away each of those 3 108s, we should be left with just what x is. So here we've got 360 minus 324 gives us what x is, and that gives us 36 degrees. So in this question, the angle x is 36. Given that a times 10 to the m is in standard form, and 2 times 10 to the q divided by 8 times 10 to the p equals a times 10 to the m, find the value of a. So to do this, I'm going to look at that division, and I'm going to take it bit by bit. I'm going to first work out what 2 divided by 8 is, so dealing with the numbers first. I know that that gives us 0.25. So now I'm going to have a look at the indices. So I've got 10 to the power of q divided by 10 to the power of p. So we should remember that when we divide these powers, we have to subtract the indices. So that means that here, where we have 10 to the q divided by 10 to the p, that will give us 10 to the q minus p. So we're nearly there now, okay? But the key thing is that a times 10 to the m is in standard form. Now what we have here isn't in standard form, because the number part, the 0.25, isn't a number bigger than or equal to 1, but less than 10. it cannot be a decimal. It can't be 0.25. The smallest number that it can be is 1. And the reason for that is simply that is just what standard form is. So if they ever ask you for standard form, that number part of it has to be at least 1, but still less than 10. So let's have a look at what we need to do then. What we can do to fix this is if we essentially bump up the 0.25 by a factor of 10, but then decrease the other side, the power, by a factor of 10, they're going to even out, but the number will look different. So what we'll have is 2.5 for the number, and then the index will become times 10 to the q minus p minus 1. And the reason why it has become that is because if we have this 10 to the q minus p and we divide it by 10, essentially what we have here is something that where we can use our index rules again. So if we divide it through by 10, it's essentially 10 to the 1, isn't it? And we know that when we divide these indices, we subtract. So that's where we're getting our q minus p minus 1 from. So now we have something which is indeed in that standard form. So what we've got here is a times 10 to the m. So now we've done this, we have the answer to part A. A is equal to 2.5. So if we now look at question B, you can see they wanted us to write down an equation for m in terms of q and p. And we have that really, don't we? Because if we look and compare, we can see that this q minus p minus 1 is equal to m. So actually, quite simply, we can just say that m equals q minus p minus 1. And that there is your answer. The following table represents the frequency of the ages of 300 participants in a marathon. So here you can see we're given a table with a number of participants, but we're asked to complete the cumulative frequency part. So cumulative frequency is all about looking at what's up to that point, so everything that came before it as well as in that interval. So let's get started. So in our first cumulative frequency box, we're just looking at everything up to 25. And because this is the first interval, it's just going to be that 15. So we'll put 15 in the box. Next, we are asked to do the cumulative frequency of everything up to 35. So to do that, we need to add together the 15 and the 45. So that's going to give us 60. So next we need the cumulative frequency up to 45 now. So that means that we also want to add on the 70. So that gives us now 130 for the cumulative frequency up to 45. Next we need the cumulative frequency up to 55. To get that, we're just going to add 90 onto the 130 we already have, getting 220. And to get cumulative frequency up to 65, we need to add that 80, which gives us 300, which makes sense considering that we have 30 participants in this marathon. That is what we would expect. So now we're asked to draw a cumulative frequency graph to represent this data. So let's remind ourselves of the information we had on the previous page. The thing that we most importantly need to know here is that we use the final number in each interval. So here we're going to plot the point on the x-axis of 25 because that is the end of the age group interval. So 25, 15 is going to be our first point on this cumulative frequency graph. So the next point now is going to be at 60 on the y-axis, but 35, again, the end of the interval for the cumulative frequency. So here we've got 35 at 60. The next point will be 45 on the x-axis, the end of the interval, and 130. So we'll plot that point now. So 45, 130. Then now we're going to do the 55. So we go along at 55 along the x-axis, and then we're going to go up to 220. Now we're on to the final point. We need to plot a point at the end of the interval again, so that's 65 and 300 high. Now we've got all these points, we need to draw a curve. Always remember to start at the point 0, 0, and then you're going to go up through each of those points, making sure you go through them all. And there we have our cumulative frequency, which starts at 0, 0 and ends at 65, 300. Here we're asked to work out the percentage of participants that are aged 35 or younger. So let's have a look at the table here. I can see that up to 35, we have 60 people. We can either look at our cumulative frequency, or we can add up the 15 plus the 45 again. So we know we have 16 people who are 35 or younger, and we also know that we have 300 people in total. So that means that we have 60 people out of 300. So to get that as a percentage, we're going to do 60 divided by 300 and then times it by 100. Now that gives us an answer of 20%, which is our answer here. If a participant is chosen at random, work out the probability that they are aged 50 or older. So to answer this, I want us to have a look at our cumulative frequency graph again. So 50 or older, let's use our graph and move a line up from 50 until it hits our curve, and then we're going to read across to see what the cumulative frequency is. So we're reading across, drawing a horizontal line here, and we'll find that the cumulative frequency appears to be around 170. There'll be a little bit of leeway here in the exam because of course it depends on your curve. So 170 people are going to have an age below 50 because it's cumulative, it goes from small up to big. However, this question wants us the probability of people aged 50 or older. So if we know 170 people are younger than 50, if we do 300 minus 170, we'll find that we have 130 people above 50 years old. Now that is what we can use to work out the probability of being 50 or older. That's going to be the 130 divided by the total number of people. So that there gives us 13 over 30. They just said work out the probability. We could give that as a percentage, but there's no need. That is absolutely fine as a simplified fraction. So our answer to this question, the probability that they're aged 50 or older is 13 over 30. A curve has the equation y equals x squared minus 2x plus 3, and we're asked to complete the table here. Now to do this, we need to substitute in the values of x into the y equation. So the first one that we need to find is what y is when x is equal to minus 2. And we need to replace each of these highlighted x's with minus 2. So let's get started with that. If x equals minus 2, then y is going to be equal to the square of minus 2, don't forget the brackets, minus 2 times minus 2, again don't forget those brackets, plus 3. Now that gives us 4 plus 3, which equals 11. If you don't get that, I can guarantee it's because that something went wrong with the brackets, so try again. So we can fill that into the table now, 11. Now let's do exactly the same with minus 1. Again, do not forget the brackets, particularly important when it's a negative number. So here we've got y equals minus 1 squared in brackets, minus 2 times minus 1, plus 3, which should give us 6. Again, any mistakes, make sure that you've done the brackets exactly how I've written them here. So the final one we need to do is x equals 2. So here we've got y equals 2 squared minus 2 times 2 plus 3, which is the same as 4 minus 4 plus 3, which gives us 3. So we can complete the table with a 3 in that place. So we've got an easy 2 marks really. Now for B, all we need to do is plot them. Remember that X is moving along the left and right, and Y is going up or down. So plotting each of these points, as you can see here, all we need to do to finish it off is to do a nice smooth curve going through all those points. And then there we go. We've got all of our marks in that question. Here we're given a circle theorems question. We're told that AB is a tangent of circle 1 at T and CD is a tangent of circle 2 at D. And we're asked to find the angle ETF, which is this little angle here, okay? So let's have a think about how we can do this. These circle theorem questions are rarely a case of you're just going to dive straight into getting that angle. You're going to have to work out some other angles along the way. So I always just think, just don't hesitate, just start working out whatever angles you can. So let's have a look at this here then. If I think about that tangent of C to D and circle 2, I can see I've got a little triangle here. And I can say that using the alternate segment theorem, this angle of TE to B is going to be the same as this 80 degrees here. So I can say that angle TEB equals 80 degrees. So if you're not familiar with the alternate segment theorem, do remind yourself of it because it's a very useful fact. So we've got that one there. See how we had to block out all the noise of the other information in this diagram to spot it really? Now, let's ignore all that I wrote there. Let's just label on that 80 degrees so that we don't forget it though. And let's think of what other angles we can work out. So I can see I have an opposite angle here. If I look at this angle ATD, I can see that that is also going to be 80. And this isn't using a really fancy rule or anything. It is just the fact that vertically opposite angles are equal. And of course, this is opposite to that 80 degrees again, okay? So we're definitely building on some information here. And now that I've got this new 80 degrees, I can actually spot another alternate segment theorem, but this time using circle 1. So let's have a look at this now. Let's imagine we've got this tangent A to B on circle 1. And then we've got this triangle made up of the points T, D, and F. So using the alternate segment theorem, just like we did before, we can work out what this angle here is. It's also going to be 80 degrees, but because of the alternate segment theorem, using that angle of ATD. So here then we can say that the angle of TFD is equal to 80 degrees, or you could have called it TFE, it would have been the same. And this is just due to the alternate segment theorem. Now we have enough information to finally work out the angle that we're being asked to find, which is angle ETF. So to do this though, I'm going to kind of zoom in on this little triangle that we've got hiding here because it's a little bit small. So on the top is the angle that we need to find. That is the angle found at the T. And then on the bottom here, we've got the 280 degrees that we've just found using two different alternate segment theorems. So then at the top there is the angle we need to find. But we've got a triangle here, so we can do this easily. We know that the three angles of a triangle add up to give us 180 degrees. So all we need to do here is 180 minus 80 and then minus another 80. And that leaves me with 20 degrees. So here the angle that we needed to find, that ETF, is equal to 20 degrees. There we go, easy peasy. So the main thing here that I'm just going to say is don't forget circle theorems. Make sure you go away and just remind yourself of the different circle theorems. Perfect for making flashcards, that topic. And just make sure that you remember the different rules. And if a question comes up, make sure that you write down each of the reasons as you go. You don't just do the calculations, because quite often you're going to be getting marks for the explanations as well. Simplify the following, and here we have 1 over x minus 1 minus 1 over x minus 3. Now we have two algebraic fractions here. In order to simplify this, we need to turn it into one big fraction. And to do that, we need to get the denominators the same. We can do this by timesing the 1 over x minus 1 on the top and the bottom by x minus 3. So we have 1 times x minus 3 on the top and x minus 1 times x minus 3 on the bottom. Now we're going to do the same thing on the other side, but this time we're timesing the top and the bottom by x minus 1. The whole purpose of this is we haven't changed the values of either of those fractions. We've essentially times by 1, but they're going to look a bit different. They're going to have the same denominator. So starting with the first one, we have just x minus 3 on the top. On the bottom, we're not going to do anything fancy here. We're just going to rewrite it as x minus 1, x minus 3, making sure we have the two sets of brackets there. Now over on the other side, we've got 1 times x minus 1, which is just x minus 1. And again, on the bottom, we have x minus 3, x minus 1. So now we've got the same denominator. Doesn't matter that they're written in different orders on the denominators, however you write it, they are the same. Now that we have the same denominator, it means that we can add or subtract these fractions. And in this case, obviously, it's a subtract. I will say, please be very careful when there's a subtract, particularly when it's an algebraic fraction. So here we have x minus 3 minus, and see I put brackets here, x minus 1, over x minus 1, x minus 3. Now the reason why I put those brackets there is because we could completely go wrong if we don't count them. That negative has to apply to both the x and the minus 1 of that second term, not just the x. That would be the very easy mistake to make. You just plonk it in front of x minus 1 and away you go. But you would not get it all right. And it's only a 2-mark question. Let's not lose those precious marks. So here we have x minus 3, but then it's going to be minus x. And then because it's a minus and a minus, it will be plus 1. And that's all over x minus 1, x minus 3. So now we're nearly there. We can just simplify the top. Here we can see we have some x's, but it's x minus x. So actually you'll see that the x's will cancel. And then you have minus 3 plus 1, which is going to give us minus 2. So here we have minus 2 over x minus 1, x minus 3. And that there is our answer all finished for you. So that's how we simplify two sets of algebraic fractions, added or subtracted to each other. First you get your common denominator, and then you add or subtract them to simplify. This is a quadratic inequalities question. We're asked to find the set of values that satisfy this inequality. So what we're going to need to do is, if we can, factorise this. Now this is a slightly trickier factorising question though, because there's a number in front of the x squared. Now there's lots of different methods that you've potentially learned to deal with these, and you can even just use a bit of trial and error, but I'm going to show you a certain method that could help you if you find these tricky. So I start off here by writing my double brackets. I know it's double brackets because all of these terms don't have a common factor. Now I'm going to have a look at the number in front of the x squared, so that's 4. And what I'm going to do is I'm going to multiply it through by that minus 1, the number on its own. So 4 times minus 1 ends up giving me minus 4. Now that I've got this, I'm going to kind of just use a similar method to how I normally factorise things. But instead of saying I'm going to find two numbers to get the constant on its own and add to make the number in the middle, I'm going to say I want to find two numbers that times together to make minus 4 and add to make that plus 3, the coefficient of x. Really now very similar to our normal method. So having a little think of that, I can think that +4 and -1 is going to be the right combo there. So I'm going to write those in my spots here. So I've got +4 in one bracket, -1 in the other. Normally we just put an X and an X in the other position. But here, this is part of our trick. I'm going to put the 4X and a 4X in each of those positions. But this is where it's a little different. We're not done yet because technically this is incorrect at the minute. I notice that the 4x plus 4 can be simplified. And by that I mean there's a common factor between the 4x and the 4. And so what I do is I do simplify that down. So I'm going to cancel essentially out that factor of 4 so that it comes down to just x plus 1. So my factorised version of this quadratic then is x plus 1 times by 4x minus 1. And that is correct, okay? So that's a method that you can use to factorise these more challenging quadratics, irregardless of the fact that this is an inequalities question. But it is an inequalities question, so we're not quite finished yet. We know that this is less than or equal to 0. Now, what I like to do next is to sketch the quadratic. It's a positive x squared, so it's just like a smiley face. I know that the curve crosses the x-axis when x plus 1, that first bracket, is equal to 0, so when x is equal to -1, or when that second bracket is equal to 0, so when x is equal to 1/4. That enables me to label that diagram and those points where it crosses the axis. Now, we don't want where it's equal to 0 like normal, we want where it's less than or equal to 0. And I can see that's the region where the curve goes below the axis here. And if we imagine this like a little number line, that's the region between -1 and 1/4. So that ends up giving us this inequality. We can say that x is going to be less than or equal to 1/4. We stay consistent with the inequality that's in the question. So less than or equal to rather than just less than. And it's going to be bigger than or equal to -1. So that's because almost like a number line, and that's why these diagrams are so helpful. We can see it's that region that x can be between -1 and 1/4, and that is what our inequality that we've written here represents. Now, final little thing to mention here, notice that that inequality is just one big inequality. It's not like x is less than this and x is bigger than this or something, like two separate inequalities. And the reason why we write it like this is because there was one single region that we have highlighted where this curve is less than or equal to 0. That single region. And that's why we give this single inequality as our answer here. Here we're asked to simplify ac to the -2 times by a cubed c. So because we're multiplying together indices here, we need to use the following rule. We should remember that if we had something of the form of x to the m times by x to the n, we end up adding those powers together. Therefore we get x to the m plus n, and we've done it. So here we've got a's and c's, and we want to treat those separately. So let's start with the a's. Don't forget that if we have an a on its own, that means it's a to the 1. So here we've got a to the 1 times by a cubed, which, using our rule, is a to the 1 plus 3, which is a to the 4. So now let's do exactly the same for the c's. I can see here I've got c to the -2 times by c, which of course is c to the 1. Using our rule, I've got c to the -2 plus 1 equals c to the -1. And so we just write that next to the a to the 4 and we have our mark. So now what we need to do is we need to have a look at this second question. So here I've got 125 over x to the 9 to the power of -1/3. So it's important that we know that the negative power means that we need to do the reciprocal. And what reciprocal really means is, if we have a fraction like we do here, is we just flip it. And if it's not a fraction, then we do 1 over that number. So let's flip this then, and then we've dealt with the negative part of this power. By flipping it, we get x to the 9 over 125. And instead of it being -1/3 the power now, it's just 1/3. So we've got a mark already now, we're doing good. Let's now have a think about this power of 1/3, okay? So when we're talking about numbers, if we have like a number to the power of a third, like we do here with this 125, we need to remember that when we've got a number on the bottom of a fraction, that's telling us to do a root. And because it's a 3 in this case, that is a cube root. So we're going to need to take the cube root of the 125. We also need to take the cube root of the x to the 9, but what does that mean? Okay, this is where another index rule comes in handy, and this is the power rule. Here we've got x to the m to the power of n equals x to the m times n. So for the x to the 9 bit, let's multiply together these powers. That's probably the easiest way to do that, whereas for the number, we're going to use the fact it's the cube root. So here we've got x to the 9 times by 1/3 using our power rule. That gives us x to the power of 3. And the cube root of 125 is equal to 5. Now, of course, at this point, we're doing calculator papers, so that's fine. We can just say it's 5. We could type it into the calculator. However, really in a perfect world, you should know that the cube root of 125 is 5. But regardless, our answer to this is x cubed over 5. And the really important takeaway of this question is make sure you know those index rules. They are so useful and they are really easy marks. A hollow cylinder is filled with 3 identical spheres. The radius of the spheres is the same as the radius of the cylinder. Find the fraction of the cylinder that remains empty. So to answer this, we need to work out the volume of the cylinder that remains empty. To do that, we're going to need to work out the volume of the cylinder in the first place, and then subtract the volume of the 3 identical spheres. Now, don't be worried here about the fact that we don't have any numbers. It's fine, we know enough. Let's have a go at just labelling this, okay? We know that the radius of the spheres is the same as the radius of the cylinder. In that way then, we can draw on the radius on our diagram, and then we can also draw in terms of the radius, the height of this cylinder. As 3 spheres fit in it, it's going to have a height which is equal to 6 radii. So now that we know this, we can go back to our standard equation for the volume of a cylinder. We know that the volume of a cylinder is pi r squared times by the height h. So substituting in 6r in place of the height gives us 6r squared times by 6r, which simplifies to give us 6 pi r cubed. So we've already done the first part of this question. Now let's have a go at working out the volume of a sphere. We should know that the volume of a sphere is given by 4/3 pi r cubed. Now, in this case, as we're not looking for the volume of 1 sphere, we're looking for the volume of 3 spheres, all we're going to need to do is take this and multiply it through by 3. So the volume of the 3 spheres is equal to 4 pi r cubed. So now we've got this information down, we can go and work out the volume of empty space. So it's going to be equal to 6 pi r cubed, which is the volume of the cylinder, minus 4 pi r cubed, which is the volume of 3 of those spheres. Now simplifying this, we're left with 2 pi r cubed. So that is our volume of empty space. Now going back to the question, we're asked to find the fraction of the cylinder that remains empty. So that's going to be equal to that volume of empty space divided by the volume of the cylinder. So we have 2 pi r cubed over 6 pi r cubed, which simplifies down to just 1/3. So 1/3 of this cylinder remains empty. ABC is a triangle. A to B is equal to 2S. A to C is equal to 3R. And we're told that D is the point on BC such that B to D to D to C is in a 2:3 ratio. So we're asked in this question to show that A to D is parallel to the vector S plus R. Now, when we're asked for a vector that's parallel to something, it's going to be some constant times by that vector. So we're going to expect it to look like some constant times by s plus r. So we need to go from A to D. So we need to work out what that vector of A to D is. And as you can see here, to get from A to D, we need to go on a little walk, and we're going to go from A to B and then from B to D. So we can say then that A to D is equal to A to B plus B to D. And that's how we want to think about it. So now let's have a look at that and break it down. I can see that A to B here is simply 2s. We're told that in the question, in fact, aren't we? So we're just going to make a note of that so we've got all of our information down. Now let's have a look at B to D. Due to the ratio that we're given, this 2 to 3 ratio, I can see that B to D is 2/5 of B to C, because there's 5 parts in the ratio and B to D is 2 parts of that. So I'm going to start by writing down here that B to D is equal to 2/5 of B to C. Now, we're not told what B to C is immediately here. We need to work that out. B to C is going to be going from B to A, so minus 2s, because we're going in the opposite direction to that arrow, and then plus 3r. So B to C is equal to minus 2s plus 3r. And we can substitute that into the equation that we have for B to D to get B to D. So we can say that B to D equals 2/5 times by minus 2s plus 3r. Now multiplying out the brackets there, I get that B to D is equal to minus 4/5 s plus 6/5 r. And that is as simple as that. We've just got B to D equals that. So now that we have this, I can see that I can substitute these two in to our A to D equation. We're nearly there now. A to D, of course, was equal to AB, which we have said is equal to 2s, plus B to D, which we've said is minus 4/5 s plus 6/5 r. So this is something that we can treat like algebra now. We can get those like terms together. And I can see I've got two different s terms there. So I can say that A to D equals 6/5 s, because 2 minus 4/5 is 6/5, plus 6/5 r. Now if I factorise that then, I get that A to D equals 6/5 of s plus r. And because this obeys the fact that this is some constant times by s plus r, we can say that it is indeed parallel to s plus r. The functions f of x and g of x are given by f of x equals 1 over x minus 2 and g of x equals 2x minus 1. And we're asked to find the inverse function of f. That's what this notation means. The way that we do this is we start by just writing it with y instead of f of x. So y equals 1 over x minus 2. And then we use this trick which involves swapping the x's and the y. So there we get x equals 1 over y minus 2. Now, and it sounds really counterintuitive, but now we want to rearrange to get the new y. And we're not going to end up where we started. This will give us the inverse function. So this can be seen as just an algebra question standalone now. And this is a type of algebra question that always trips people up when the thing you want is on the bottom of a fraction. Okay, so I'm going to show you how we deal with that. And remember, you can apply this just to a normal algebra question as well as an inverse function question. So the key to these questions is if the thing you want is on the bottom of a fraction, you start by multiplying both sides through by that denominator, by that bottom part of the fraction. And this fixes it because now that thing you want isn't on the bottom of a fraction anymore, okay? So the first step that I have done here is I have multiplied through by the y minus 2, and I've treated it as a big bracketed term, and I've just brought it up. So now I'm going to multiply out those brackets. So that gives me xy minus 2x, which is equal to 1. Now I'm going to start rearranging this to get the y on its own, and it's just a normal linear equation now, so it's a lot easier. I'm going to add the 2x. That gives me xy equals 1 plus 2x. And then I'm going to divide by that x, which is multiplied through by the y. And that gives me y equals 1 plus 2x over x. which I'm just going to replace the y back now with f minus 1x. So I can say f minus 1x is equal to 1 plus 2x over x, or I could also write that as f minus 1x equals 1 over x plus 2. Because if I divide each individual term there, the 1 and the 2x by x, that is what I get. So now, gf of x. This is a composite function. And the way these work is you kind of got to go backwards, okay? So what we're going to do is we're going to put the f of x function in the place of the x in the g of x function. So you can see there we've got that little x in the g of x, and we're just going to plonk in what f of x is. So we're going to put in the 1 over x minus 2 in place of the x. That ends up giving me gf of x is equal to 2 times 1 over x minus 2 and then minus 1. And that's what we get there. We can leave it like that, or we could multiply out the bracket, giving us 2 over x minus 2 and then minus 1. And that there is our answer. We could go a further step and write it under just one denominator, so bring the 2 over x minus 2 together with the minus 1, absolutely fine, you would still get your marks. So now this is a bigger question. We're asked to solve the equation f minus 1x is equal to gf of x. So let's remind ourselves what both of those were. So we've got 1 plus 2x all over x is equal to 2 over x minus 2 minus 1. So really you just need to start off here by equating those to each other. Now here actually, I mean there's loads of ways we could rearrange this, but I probably would choose to write that gf of x as a single term. So I probably would try and write it as a single fraction now. The way that I would do that is try and rewrite the 1 as a fraction with x minus 2 on the bottom. And the way we do that is simply multiply the top and the bottom by x minus 2. That gives me 2 over x minus 2 minus x minus 2 over x minus 2. So I can write that now just to have that single denominator of x minus 2. And on the top, I end up with 2 minus x, but then the minus and a minus makes a plus 2. Be very careful of that. That's a place where you could definitely make a mistake. And then all over x minus 2. And if I simplify the top of that fraction, get those 2's together, I can end up simplifying that down to just 4 minus x over x minus 2. So there I've simplified the right hand side of that. So let us start afresh now and just rewrite this out. So I've got here 1 plus 2x over x is equal to 4 minus x over x minus 2. So I've just freshly rewritten that, and I'm just going to think about that now. I'm not going to think about the rest. So what I would do in this case, and again this is the same if this was actually just an algebra question rather than a functions question, is I'm going to multiply up those denominators, okay? Again, the thing that I want to find being on the bottom is never going to help us, so multiply through. So I'm going to cross multiply through by the x minus 2 and also by the x. That ends up getting rid of those denominators and bringing it through to the other side. Here I get 1 plus 2x times x minus 2 is equal to x times by 4 minus x. And now I need to multiply out those brackets. So 1 times x gives me x. 1 times minus 2 is going to give me minus 2. 2x times x gives me plus 2x squared. And 2x times by minus 2 gives me minus 4x. So then on the other side here, we've got equals x times 4, which is 4x, x times minus x, which gives us minus x squared. So we've multiplied that out. It's looking good. And I can see here that this is going to end up being a quadratic equation. What I want to do then is get everything onto one side, group all the like terms together, and have the other side equal to 0. So 2x squared plus x squared gives me 3x squared. Now let's look at the x's. X minus 4x gives me minus 3x. and then I need to subtract 4x from the other side to move it onto this side. That gives me minus 7x, and then I've just got the minus 2 on its own, and then that's equal to 0. Here I can clearly see I've got a quadratic equation here, and the fact that the question asks me to give the solutions to 2 decimal places tells me that I can't factorise this, and it tells me to use the quadratic formula. So I'm going to make sure that I use my quadratic formula here. If you don't know this off by heart, remember it is given to you at the front of the paper, okay? So let's write it down and put it into practice. So we should know that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And the a is the coefficient of x squared, so in this case the 3. B is the coefficient of x, so in this case minus 7. And the c is the number just on its own without any x's, so that's minus 2. So if we substitute the numbers in here we get that x equals minus 7 plus or minus 7 squared. Don't forget the brackets because you will make a mistake there if you don't include them. And then minus 4 times 3 times minus 2. And then all over 2 times 3. So remember that square root is included all of that stuff there, the minus 7 squared, minus 4 times 3 times minus 2, and then everything is divided by the 2 times 3. Be really careful of those brackets though, because if we just did minus 7 squared, the calculator will actually give us the wrong answer. It needs it spelling out for it, okay? So there we have done that. And then now we're just going to tap it into the calculator, and we're going to do it in 2 different blocks. We're first going to substitute in the positive, in that plus or minus, and that gives me x equals 2.59 to the 2 decimal places that we need. And then if I now just go through and edit that equation, I don't need to write it all out again. If I delete the plus and change it from minus, I end up getting my second solution. And that is minus 0.26 to those 2 decimal places again. So make sure you include both of those solutions to get your final mark in this question. A cuboid ABCDEFG is given below. We're told that a to x to g is in a 2:3 ratio. Let's label that information on now. What we should understand is if something's in a 2:3 ratio, then that a to x section is 2/5 of a to g, whereas x to g is 3/5. That's because there's 5 parts in that ratio in total. So we also know here that the length of b to g is equal to root 50. So I'm going to label that on as well. It's always good in a maths question, especially a lengthy one like this, to label or make notes as you go. So in this question, we're being asked to find the length of x to b. And here you can see this is a 6-mark question, so it's not going to be an easy one. There's going to be lots of steps to it. So the first thing that I would do here is I would look at this triangle ABG. And I can see that that's actually a right-angled triangle. I can use that fact to work out the length of A to G, because what we have is a right-angled triangle, and so we can use Pythagoras' theorem to work out that length. So, using Pythagoras, we can say that A to G squared is equal to A to B squared plus BG squared. Of course, we know some numbers for those, so let's substitute those in and rearrange this to find out what A to G is. So here I've got A to G squared equals 10 squared plus root 50 squared. Now that leaves me with AG squared equals 150, because I've got 100 plus 50 gives me 150. Now if I take the square root of that, I get root 150, but this also simplifies in a way that will make the maths a bit easier moving forward. I get 5 root 6. Now that's going to really help us moving forward. So here I can see that I need to find eventually the length of x to b. So I can see I can make a little triangle using x to b as a side. Now this triangle here is not a right angle triangle. That means we can't use SOHCAHTOA anymore, or Pythagoras' theorem. I can see though, I know the length of b to g, but I can work out now the length of x to g. Now I can see that that's going to be 3/5 of the length of a to g. So I need to do 3/5 times by 5/6, which leaves me just with 3/6. You could have done this to work out a to x and use that bottom triangle instead. I'm using this method here. So whatever suits you, so long as you get the right answer in the end. So now I've labelled that on. I can see here, I have this triangle that's not a right angle triangle, but I've only got 2 lengths on it and I need to find the third length, don't I? Now, that suggests to me that I want to use cosine rule, because cosine rule always has 3 sides and 1 angle. To use this though, we need to know an angle. I can work out what that angle A to G to B is, or X to G to B, by using SOHCAHTOA, using this right angle triangle of AGB. See, I'm just going to draw this on here to remind us of that triangle existing. See, it's a right angle triangle there. So I can work out that angle of AGB and use that later down the line to work out this length XB. But let's forget about XB for now. All that we care about is finding this angle AGB in this right angled triangle. So if I look at what sides I already know on that right angled triangle, I can see that from that angle I have the opposite angle, which is the 10 centimetres. And I can also see that I have the adjacent angle, which is the root 50. So thanks to SOHCAHTOA, we've got everything we need for the TOA part. So we've got tan theta equals the opposite over the adjacent, which is going to be 10 over root 50. So if tan theta equals 10 over root 50, I can say that theta equals tan to the minus 1 of 10 over root 50. So this is just something we need to put into our calculator now, hit equals, and then we'll find that theta is equal to 54.7 degrees. So now we have that angle, and that angle is not only that angle of this right angle triangle, it's also one of the angles of that non-right angled triangle, which is going to hold the key to us finding that length of XB. So let's scrub out that green triangle now, that right angle triangle. It's irrelevant to us now. Now that we have that angle, we don't need it anymore. So let's just focus on this pink triangle XGB now. You can see, like we said, it's not a right angled triangle. We know that one of its lengths is root 50 and the other length is 3 root 6. We need to find its third length, and we know that the angle opposite that length that we're trying to find is 54.7 degrees. Now, due to the fact this is not a right angled triangle, and once we get the answer we'll have 3 sides and 1 angle, we know that we need to use the cosine rule. So let's remind ourselves, the cosine rule states that a squared equals b squared plus c squared minus 2bc cos a. So the important thing there is the little a is talking about the side which is opposite to the angle that we know, that big A, okay? The b and the c, it's irrelevant to be honest. You can use those in either order, just as long as the angle that we know is opposite the side that we're trying to find. So let's put the numbers in now. We've got a squared equals 3 root 6 squared plus root 50 squared minus 2 times 3 root 6 times root 50 times cos 54.7. And we just need to put that into our calculators now. And don't forget, once we get that, that is a squared. This would be a really common mistake people make. They hit equals and they think we're done. Okay, so here when I put that into the calculator, I end up getting that a squared equals 43.7 43.947. Now, I need to remember to square root that to get just a, which in this case, that a is our xb. Don't forget as well to always check at the end of the question how many decimal places or significant figures we needed. This question asked for 2 decimal places, and so xb is equal to 6.63, which we got by square rooting the 43.947. So there we have it. There was a lot of steps in that question. It involved not only 3D trigonometry, but it involved our SOHCAHTOA, our Pythagoras within that topic, and then it also turned a little bit into our sine and our cosine rule topics, with some ratios thrown in too, to be fair. So really a lot within that question. Definitely a level 9 question. This would be your stretch question right at the end of the paper. Don't be too intimidated if you couldn't get all of those marks. They are just for the very, very best students. So if you didn't get every mark in this, don't worry. And just focus on maybe getting 1 or 2 marks just by using, of course, the fact that we've got this 3D trigonometry and we can use Pythagoras, even just that. Be happy with it. Get a mark or 2 and then just don't stress about the rest, because like I said, to get 100% in this paper would be phenomenal. No one really is getting that. So don't be afraid of questions like this, just give them a go, and good luck for your exam.
Ouch! This is why in some videos I'll explain scratches.